All right. So today in Ghana is holiday, and I gave an assignment earlier to my friends and my colleagues. So I want to do the assignment. It's actually in R. So we want to create some. I think let me share my screen as quickly as possible, and then yep. So I think let me just pull up the assignment. So this was the assignment, and I'm saying that okay. In assignment for the holiday, you are to create 6 different vectors of professionals or and but the network is back. So what we let me share my screen and see what I can continue from there. So this is where we were, and then I was just trying to explain how we are able to. The first question was to create some we've created salaries using this function, which we call the short sample. You create integers. You can also use a round if to create. You can use sample itself. You are sampling from 17 to 61, and you want 20 of them without replacing any of them. Another way of using distributions like the normal distribution, Poisson. In this case, I'm using normal distribution to create 20 variables with a mean of 20 and then a standard deviation of 5. Frody explained that, what that means. So we did that. Then we came to our next question, which is supposed to be how do we create a data frame? Now, once we have created, I mean, the once we have created all the vectors, it's very simple to create a data frame. We gave it this particular variable name, and we use the function data frame. And then we now put all the vector that we have created, like the profession we created top here. We now put all of them using the data frame as a function. When you use that and then you do all this, then you just run it. Your data frame is created straight away, and then we have our data frame. So we could easily print our data frame from here. And then if I print my data frame from here, then what is it? You can all see the data frame being created. That was the second assignment we needed to do. See that my data frame has been created. It's inside my. So you can see that I have a data frame of profession, salary, height, weight, age, travel distance, and in that order. So that was the second question we needed to answer. The third one was adding a new column of BMI. BMI, you need to know how to calculate BMI. BMI is actually the weight of the person divided by the height square. So a height square, the height we've got height here, which is indicated. We've got the weight there in kilogram. So now what do we do? This is the formula I have indicated on top here. So we need to. So we decided to create this variable called BMI first of all, and then we said all till it persist all the columns that are found in that particular data frame. Then you choose, the one you want. Let me demonstrate and maybe you can see. If I do like this, you see that when you put the data frame and you add $sign to it, it will list all the columns. So you select the column you want. I want the column of weight. And then the column of weight is divided by the column of height square. The height square means height times height. So how do I get the height? You have to go to the data frame, select the height column, and then multiply it by, you select the data frame, go into the height column again, then you multiply that one also. What do you multiply by the other one? So that will mean height times height. So that's what you have in this particular bracket. But in computer language, if I leave it without putting it in parentheses, uh, is the order of how it will execute will be different. So you always put it in parentheses. The rounding. If I well, uh, because I added what the brace is, that's why I didn't. So the round one here means after we have done the calculations, we've divided our weight by height square. We should run it up to one decimal place, and that's what we did for the BMI. So if we run that particular line, we can see that our BMI, I think something is missing somewhere. I don't know what is missing. Yep, the BMI it has run now. So when we print our BMI, definitely we're going to see that now they are in one decimal places. That's all. Now what is next is add the BMI as a column to the data set. And so what do? We already have our data, which is prof underscore professions underscore data here. So you bring when you I've already said that when you bring a dollar sign, it gives you an opportunity to list all the columns that are there. So the dollar sign actually, so if you want a new column, just you put the data and then bring your dollar sign and add the name of the new column you are bringing. Then that's the new column I have, BMI here. And then where is that new column getting the data from? It is getting its data from this BMI that we have calculated to be. And I now print this particular so that was then the fourth question was using three of the vectors to create. We are using three of the vector that we have already created on top. If you these are the vectors that we created, salary, height, whatsoever, and then we are going to use just three of them to create, a data. So to do that, I just decided to name the variable data. Don't worry about the spelling because I've already got another data with the same spelling, and in R you cannot have two variables with the same name. So that's why I spell it this way. Don't worry about that. So you will come and do if so. We are using two of the vectors. We created a vector of salaries, a vector of concatenate sign to combine all of them as a data into this. And then when I come, I can use my matrix here, and then I have my matrix here. Then the matrix, the syntax is you have the data, you have your row, you have your columns, your number of columns. Because I combined three and they are 2020. So that will be 60. So number of rows 10, number of columns 6. So 6 times 10 will give you 60. So is I'm sure by row is true. But I decided to add the dimension names. So I decided to create the dimension names around here. I could have created it quite earlier. But later on, I wanted to do something. That's why I added it. So the dimension names are there. The dimension name, mostly, you have to create this as individual vectors. And if you check, you can see down here, I've already created them as one. Then I've also created another one here. And then what is it? They're all there. So I created them and I just added. If you do not add it and you end at true, it will see run all right. You will see run and you have your matrix all right. So I came to just run that line, and then that is it. It runs properly. I can if I print the matrix, you can see that the matrix will have their names and whatsoever. So if I fold this up, you can see the matrix is already there. So the matrix is here with the names, row names, and column names all intact. To uh, to cook All right, so the network kept failing me small, small because I'm just sitting somewhere. So I was just about finishing. I don't know when it. So I'm actually. And so the screen is sharing quite momentarily. I was saying that it's very simple to do that. You just have to create just like you have row names and column name as vectors, and then also create the department names as also a vector. Now, when you have finished the array syntax, where you have your data and your number of rows and columns, I'm talking about this line here, then the next thing is dimension names. And the dimension name, you use the list function to list them according to how you put them here. So we started with row. Here it must also be row in columns, and then the what are the matrix names or the array names. So when we finished and we ran it, we actually saw that what is it? It printed properly, and so we printed them here. And let me fold up so you can see that now we have column names and row names, and apart from that, we have the matrix name. Now we have department one, department two, department three in that order, and then that's how it is. Uh, and that was all the assignment we needed to do. I think that I just decided to add a little of something here for us to see. So uh, I wanted us to do correlation analysis. So if somebody walking distance, is there a relationship between your walking distance and where and your salary? Is there a relationship between your salary and your weight? Is there a relationship between your salary and uh, whatsoever? So all the features we have here, let's find out whether there's a relationship between them. So I decided to use I decided to install a package called the GG core plot. And then the GG core plot, I can actually obtain the correlation. So I decided to obtain the correlation. So you just do core and then you bring the matrix, the name of. In fact, in correlational analysis, you use your data must be in the matrix form. And that is the reason why all this while I've been stressing on like how to build matrix data or array. There are some analysis you want to do, the data have to be in a particular format. So to do a correlational analysis, we need to use the matrix. So, and we have already built our matrix, which is on top here. Um, our matrix is here. So that's the data we're going to use to check our correlation. So I came here to do that. You just use the core, and then the core comes with a package called GG core plot. So I install that particular package, and I then have to load it. Loading means you library when you run it, uh, uh, if I run it like this, then it comes. So Okay, so uh, it appears the network is okay. So I think I just have to finish up. I'm not too sure. All right, so this is actually where I was, and this was the what the graph we plotted. We got it from here, and then we could. So we plotted our graph here. We generated our plot here, and we can actually see the relationship between all of them that we have plotted. So let's have a graphical view, and then so we can see that age and then profession. There's a very small correlation between your age and your profession. So that's how we interpret it. We can see that your salary and your travel distance has no correlation. In fact, in interpreting this kind of plot, you're always looking at the size and the density. Come and look at the key here. You see that when the color is deep, it means there's strong correlation. Up to this color, it means this one is negative correlation, and this one is negative. So it means that if we have, let's say, travel distance and age, and it is a strong correlation, we are saying that when you are what is it? You are aging. There is a strong correlation between your travel distance and your age. I'm not too sure people will have to go on a long distance if they are aged or they are quite what is it, rich in age. So weight, what about weight? Your weight and your profession, no correlation, or if in there, but quite small. But your weight and then your salary, there seem to be a little bit of more correlation than your weight and your profession. So that's how we interpret it based on the density of the color, and then of course the size of the circle. I actually decided to choose circle. I could have chosen a different format. For instance, if you come to the if I didn't put this there, for instance, if I had just closed my brackets here, and I decided to hashtag the rest, then you would have seen that if I generate this kind of plot, it will be different. But in this case, I need to close this one first. Then let me see if I can, generate that plot again. All right, so that one is there. I can zoom it. So these are squares. But I see that this way it was difficult for you to see it clearly. That's why I had to, choose the circle using the method.